Guess what? The ProxOS Gaming. Um. Yeah. So. I mean, something can count. I'm just. Okay. Hey, it's playing the current time. Is it? Wait, yeah, it is. Discord pulls up a Discord invite with 20 people in it. That's great. System file explorer. No, I mean, okay, we're just in here. Okay. Can we rename this? Oh, Dave is great. This is amazing background noise you continuously have. I don't know how to turn it off. Menu. Oh my god. Shut up. How do I turn this off? It's just frame rate. Show advance. Okay. Oh my lord. Sure, you can lock going and exit codes too. Alright, welcome to the ProxOS manual. So this compass guide, soon hobbyist professional no prior knowledge crowd. Count set up. Press the local count. Turn my workspace. Check the menu bar. System. Develop. Debug about programs. Code editor. What menu? Code editor. Bob's your fucking uncle. There you go. Command name and have parameters. Comments. Binary, which have in your source code, you can see by opening the window to compile and run the program. And this is where the tax are. Okay, okay. I see where we're going. We're cooking now. Data types. Oh no, we have data types. Bytes, unsigned bytes, shorts, unsigned shorts, integers, unsigned integers, and floats. Oh god, it has floating point inaccuracy. Constants are fast storage type. But lack flexibility once code is compiled. The values are immutable. Oh no! Wait. Sorry, I kind of skipped in the page. You're telling me the storage types have different fastness. So the number of registers. When a large number of registers so precisely, memory is preferred option. Short type square as by 2, and bytes have no alignment notation. Okay, so we got jumps. Okay, so we have basic commands. Looks like all of these you can usually, you could put an additional parameter to specify where you want it to go to. We also have trigonometric functions, which is neat. Commands. So these are all keyboard commands. Okay. Equal, not equal, less than, greater than. We have a full range of jumps. Available data types on. Special commands exit and sync. Ooh, okay. Casting. I wonder if that requires any sort of. I wonder if that's like immediate, right? Or if this actually like does something on the hood. Static analysis compiled. Okay. So, addition. Program not compiled. Okay. Can we make it? Code editor not opened. Program now contains 0 commands. So, what? Okay, let's see here. Alright. We got all the way down to Game of Life. Okay, that's fun. Oh, that's cute. Alright, I wonder display storage, which the second passes. So is it actually talking about clock cycles on the hood? Or is it saying like, hey, you're going to actually need to do it? Here. Anyway. So what registers? Commands can read inputs from memories. They create outputs to. Okay. Yeah. Okay. So you don't need to do anything fancy. So if you could just do write result. So this is just like a single command. It's addy. You want to write it to memory location 8, and you want to add adders 0 and adders 4, right? With output out of code. Okay. Addy, not add. How do we code viewer? Runner. So add P2 to P3 and output is P1. That looks right. Okay. Got it. We created it here. Comments. We don't have any comments. Constants. We have constants. Labels. Winner. I need to compile. Command parameter incorrect. Made by constant. You can do all with made by constant, right? Constant, yeah. Add. What's the star for? Do you need star? Does it require me to like write a star after everything? No. It says add E. What's with the I? Oh, it's data type. I see, okay. So you want to add 2 integers, so it's add I. And we compile it. Program now contains 1 command. We run it. And it says this is out of code. With output none. You're not outputting, we just... We're going to finish on line 1 with output out of code. But we're writing it to memory address 8, right? Do we need to specify your X thing? Compile 1. Okay. Yeah, that's it. Fantastic. Application. So this should be Molly, right? And no tricks yet, presumably? Yep. Maximum. Alright, so we don't have any, like... We do have a max? Okay. Okay. And they're all inches? Yeah. Alright, maxi... MX0, MX4, it's MX, right? Let's look at examples, yep. Maxi, MX0, MX8, and MX12, MX8, MX0, and MX8. And then it gets outputted into MX12, which is what you want, and then we want to exit. So compile it, compile successfully, run. There you go. Shorts. Subtract 2 shorts, and shorts are S. So you want to write into as 4. What's n 0 and 2, right? Yeah. Divide 2 floats. That's 8. 4. Compile 1. Yeah. Simple casting. Convert a float to an integer. Write the result into manually as 4. Alright, well that's a special thing, right? Cast, okay. Cast. From float to integer. That's a memory address 0 to memory address to memory address 4. What's in memory address 0, and we want to exit. Exit gracefully. Stop. Compile 1. Compile. Command parameter incorrect. So it's float to integer. Do you have an example of casting? No. Oh, is it just this? You don't have any casts? Okay, compile successfully, and there you go. Bob Bing Bob Boom, Bob Junkle. How are you doing on the leaderboard? Oh, hell yeah. 8th place? Okay. That's funny. Okay, simple bets. Perform a splitwise OR on 2 integers. Okay, memory addresses 0 and 4. Perform a bitwise and between previous result and integer. And memory address 8. Let's result into memory address 12. Since we have 3 memory addresses anyway, or 4 if you include the output. So we don't actually get to save anything by like doing any clever XORs or anything. Not that they have XOR. Huh. No XOR. Only and no R. I mean, that's all you need, really. But, hey, perform bitwise OR on 2 integers. Alright. So, RE, M0, MX0, MX4, and then the we want to output to MX12 and MX8 and MX0. Compile successfully. Wow. There you go. Simple loop. Add all integers between addresses 0 and the first memory address with an integer value of 0. Okay, okay. So now we're actually starting to cook here. I know. We're going to actually have to use registers. So its abbreviation is R for them. I'm hoping. Okay. So between address 0 First one is so. Let's say here R0 is. Do you have like nice labels? Can you label this as something else? Okay. So dot point reader equals R0 dot summer equals R1 Oh, you don't do equals. Does this compile correctly? Yeah, looks like. So see, we write the result into many as 0. You don't even need a summer. So we add let's add and we put it into the first index and then it's 0. And we add between what's at 0 and what we're reading right now. And we need to skip the first one. It doesn't work if we add 0. No, the first thing we do is we add one to put it into R0. The purpose of doing this is to mx reader so we add one to reader. No, because integer is a 4-bit, right? Yeah, 4 bytes. So this needs to be 4. Add to 0. And then we need to jump if not equal to 0. We want loop mx capital R reader and 0, and otherwise going to exit. So this is compile. Line 6 was parameter incorrect. Really? Add intro? Really? Do you want me to do this? That's all I'm saying. But, so if I make it lowercase, do you not get confused? No. So confused. Dot reader is okay. So do we do, what about this? R reader. MXR reader. No. Really? Okay, what? Nope. You want to be integers. Okay. No, you don't. Command parameter incorrect. You have the loop. MX0. Yeah. And we can put in constants, right? Yeah, reads input from constant. Jump if not equal. Oh, it shouldn't. Thank you. Alright. Program now contains 4 commands. If you run it. Okay. Fails if first integer if mx0 equals 0 and mx1 equals does not equal 0. But that's not in the cards for the test input. Mwahaha. Alright, so you could save this actually as a simple loop. But now we make a new one. Even counter. Count the number of even integers between memories as 0 and the first memory as with an integer value of 0. Alright. We go loop. So first thing we do is we add 4 to R0 because R0 is going to be the pointer. Going to modi what's we want to put it into mx0. You want to put it into R2, R1. What's that? And what's being put into by R0 and taking it, modulating it by 2. First things first, we gotta to modulo mx0 by 2, and then we can add the R0 by 4, and you want to modi put into R1, and then we want to add mx0 to R1. Even inches. And number of even integers. Even integers, you say? Because I want to XOR it by 1. Right? That's what I want to do. I can't. It's a pain. I do. I really do. I don't want. I don't want to like do. I don't want to branch, right? I don't want to branch on whether it's even or not. Right? That's just way too much time to be spent doing that nonsense. I don't want to, but I don't know how to. Oh, negate. What's maximum integer? Okay, so my idea is we're not going to even use modulus at all. We're going to OR it with B11111, whatever. B111, whatever, and then it's going to be a 0. And then we're going to negate the result. And then, so if it's even, we get a 1. If it's odd, we get a 0. And then we add it to mx00, right? So what's the biggest value for an integer? It's that. Can we like just put in raw binary? No. Okay. Magic is integer 2147484 and then this needs to be a 6, right? We don't need to display. How do we debug this again? Debugging. Open register view. Okay, where the fuck is register view, though? There you go. See them as bytes. But yeah. So, So the basic loop, right, is going to take what's at going to take what's at mx_0, right? We're going to and, is it and I? mx00 mx_0. We're going to AND it with the magic. We're going to output it to R1. And we're going to negate R1. Going to add mx going to actually do it in place. Yeah. And going to add mx0 to mx_0. Yeah. And then to add 4 to R0. And then jump not equal to 0 to loop R0, mx_R0, and 0. Now the issue with this, right, is that this is not going to be, so what happens for the first one, you know? Is there a way I can do it so that the first one isn't, Oh, obviously we're going to exit. Um, 19. What do we do? We compile this, right? Line 5 is incorrect. Negate integer. Now I step to it. Don't know which thing I'm in. How do we debug at the start? Do breakpoints. Ooh. What? unpause. So we need to look at the memory view. Yes, we have 0 and 4 in the first spot. So let's see here. We take for putting it. We're ending it with magic. And these as ends. Oh, and that's the thing. Okay. You should be eyeing it with magic, actually. Yeah. What? They mention these are all bytes. Can I do this? Because it doesn't know it's meant to be. These are bytes, but I'm in the 4-byte range, though. Because negation, right? What's this bitwise negation? It's this bitwise negation. Should I assume it work? I don't want to cast it. Yeah, well, I'm not casting it. It's fine. But I'm eyeing it with magic. Okay. Should I place magic, like, itself? Okay. Stop program. Run it. Okay. Oh, it's being put into here. Oh, okay, yeah. View as ints. Wait, actually, yeah. Stop. Compile. Play. This needs to be. Okay, stop. Compile. Play. Oh, because bitwise, it's negative, all of that, right? So actually, we want to have it as. Okay. Save this as even counter to do. Save. Let's make a new program. We're going to. What are we going to do? We're going to move to MX0, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. And then to MX1, MX2, MX3. Next, you exit down here. But yeah, so it's going to be a 0. So you can go to sandbox. You can compile this. We're going to stop. We're going to compile this. This move, not care. Move. Yeah. Move it from P2 to P1. I mean, command parameter incorrect. How do we do bytes? I'm going to 1, 2, 8. Fine. Can we not do this? 1, 2, 3, 4, 5, 6, 7, 8. Is this so long? Oh my lord. Actually, isn't it typically 7? You really want me to write that as freaking numbers? Oh my god. Okay. Alright, play. Use bytes. Oh, it can actually make them U bytes. Yeah, just make them U bytes. Some unsigned. There you go. That'd be a lot easier to reason about. And make it 255, 255, 255, 254. Right? So you want to do one less than max. This is U bytes. Yeah, okay. I think it's doing like some, like, is it 2's complement it's doing right now? Oh, I can't tell. But you stop this, we compile it. So we run 2552, and then as an int, this is this number. Great. So if you save this as 1 less than int max. Say that's going off screen, but whatever. You go back to even counter to do. And so our magical, right? Because if you go to unsigned bytes, it's like this, right? It won't let us see its bits. But yeah. So here, the magic number is -167777217. Sure. So now if you stop that, we compile this, we push this, it's paused. Alright, we negate it. Yeah. Yeah. It's little Indian. It's little Indian. It's little Indian. Okay. Stop. Open, 1 less than max. This needs to be 2 for 4 then. Compile this. Run this. 2 for 4. Let's go to ints. It's -2. Okay. Save this. Open this. I want to OR it with -2. Go back to even counter. And this. 254. It gets ORed with -2. Negated. Sorry, what? Okay, somehow I succeed on some of these. But yeah, let's do it properly. Is there like a no up here? Yeah, I mean sync is no up because we don't have anything. Okay, so stop, compile, one. One is paused. So we have 4 here. If you go to look at its byte representation, it's little endian, right? It's little endian. So it's just 4 here, right? You step forward 1. Now in line 3. You step forward again. Unsigned bytes. You have this, right? And it looks like this. We bitwise negate it. So now you get just 1. That's wrong, isn't it? No, it's right. It's right. It's right. It's right. Right. Yeah, we get 1 because it's even. Yeah. Okay. Okay. And we're going to want to add to R1 and then we want to move R1 to MX0. And we don't need to do this anymore. Compile 1. There you go. It's chugging. Forgive the Lord for his chugging. Wow. Do you be going up there? Ha 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 ha! See Leo for that. What? Okay, leaderboard. How does this work? Where's the leaderboard here? Programs. Okay, I'm pulling up the Discord. It's very important that we ask on the subreddit, on the Discord, how the leaderboard works. Anyway. Maybe you do jump. You don't need to gate it. You don't need to gate it. You could jump immediately right here. Oh, it's because we're sinking. We are sinking. Okay. Okay, now we can be clever. Now we can be clever. Now we can be clever. That's a lot of things. Wow. Because we could just jump here. It's in the game. You can have jump. Let's add run. When pause. So what's in here? Well, if you are, it's -2. It's just that we know it's even. Right? So instead of here, we have a jump. So if it's not equal to -2, that should be a little bit better. Still not to statements level. How? We just end it with 1. We end it with 1 and then... Wait, yeah. Wait, why did I do that before? Wait, no. You can't end it with 1. We add it. We add. How does carryover happen? Okay. Save as pretty good even. Right, okay. Because we could, if it carries over, okay, so we make a new thing, right? We add, to R0, add bytes 255 to 255, to R0 to 255, 255 and 1. Right, let's see with this. Pileless. Command parameter incorrect. Really? Can't add bytes? Yeah, you can. What? do 0. Does that compile correctly? No. What? Oh, 235. Yeah. Unsigned bytes. Bytes are bytes. Why would you not want to unsign them? Compile it. It works. Okay, so this, unless things went, yeah, 235. Okay, stop that. Go to 1. We compile it. We run it. Okay. Go to 2. Compile it. We run it. Okay, so how are you doing this before? We're ORing it with -2. And then jumping. We're adding 1. So we can use 2 commands if you just add it every time. No, this would be worse. You want 1 command and then adding it. That's the only way it'd be better. Yeah, you want 1 command that can do all of that. We could read them as bytes. Even. Yeah. It makes more sense to read them as bytes. I'm thinking this could be some other command, right? It doesn't need to be movie. It could be some other command, so we can actually compact it more if that helps us. Why? How would that help us, though? I got it. I got it. So we take the modulo of it and, to be fair, this is like a complete different solution. Right, does it still work? Yeah, it does. Okay. We take its modulo. Modulo 2 and install it into R1. MXR0. We add forward to R0. And jump if it doesn't equal 0. Loop MXR00. Does it remember what's in the registers? I don't think it does. The cast is only being smart about it. Yeah, I mean, let me just like divide R0 by 4, and then sub into MX0, R1 from R0, and then exit. So that should work. Okay. So we're at 4. What is this, Y2? So we add 4 and continue on. 7 is not for this Y2. So 1 gets into that. You add it. Oh, this should work. No? Really? Oh yeah, okay, now I'm getting check marks. There you go. So now we go to the leaderboard. We tied statement solution. Well. Simple loop. This was a triumph. Anyway, I spent way too long working on that. We can say this as even counter condition addition. Memory address contains an integer. If you manually address 4 and the first memory address with an integer value of 0. Only add them if they're less than A. Oh, I'm tired. I think I'm going to stop for now. See y'all on the flip side.